Okay, so it says that M is the midpoint of KL, so point M is the midpoint of the segment KL. And what that means is that this side of the segment will be the same length as this side, it being the midpoint, that's the middle, so each half would be the same length. So therefore, we can say that segment KM is congruent to segment ML. Even further. Okay, and then we have definition of segment bisector. Bisector is something that cuts something exactly in half. So here it says that segment BD bisects AC. Bisects means cuts in two equal pieces or two halves. So it's saying that segment BD bisects AC. So knowing that it bisects, that means this side, this segment is the same length as this one. So AB is congruent to BC. Okay, and then reflexive property, we saw this one a lot yesterday. It's where the triangles have a shared side. So when the two triangles have a shared side, then we can say that segment JL is congruent to segment JL. Okay, and I'm going to continue moving down. Now we're going to talk about angles. Now we could use reflexive property for angles as well. So for example, we could say that angle B is congruent or equal in measure to angle B. So our given is actually this picture here. So what we have going on in this picture is saying angle B is equal to angle B, which, duh. But why it's saying that is because you have a triangle here. And then another triangle here. And these two triangles share that angle. So that's why it's saying angle B is equal to angle B. And then right angles theorem, what this means is right angles are all congruent. So if our picture right here, if given that angle G is a right angle and angle K is a right angle, then angle G is congruent to angle K. And then definition of angle bisector. Just like with segment bisector, bisector breaks something exactly in half, so the two pieces are the same measure. When we're talking about an angle bisector, it's breaking the angle into two equal parts. So here it says that BD bisects the angle ADC, so this angle here. So that means that this side and this side are the same measure. So we can say that angle ADB is equal to angle CDB. And then last but not least, vertical angles theorem. As you should know by now, vertical angles are congruent. So if we have a given that looks like this, these would be vertical angles and they're equal in measure. So we can say the angle NPL equals or is congruent to angle MPO. Okay, and then moving up this way. Parallel lines and transversals. This was a few chapters ago, but it's being incorporated now sometimes. So right here it wants alternate interior angles for this shape right here. Well, shows the parallel line right here. It shows that arrow. And then a parallel line right here. Again, this arrow shows that those two lines are parallel. And then what we have is this line would be a transversal. And it wants alternate interior angles. Well, for that transversal, this angle right here and this angle, they would be alternate interior angles. And alternate interior angles are congruent. So we can say that angle S is equal to angle T. Then we also have a transversal right here. And again, alternate interior angles would be this angle right here and this one here. And alternate interior angles are congruent, so angle R is equal to angle Q. And then vertical angles are congruent too. So these two triangles have all the angles the same measure, meaning they are similar. They could be congruent, but we don't have enough information to say they're congruent. And then this example, similar. We have a parallel line right here, another parallel line. This would be our transversal. And alternate interior angles are congruent. So this angle would be equal to this one. We can say angle BDC is equal to angle ABD. Okay, and then we have corresponding angles theorem. Just a little reminder, corresponding angles look like this. You would have parallel lines here, and then the transversal corresponding would be like this angle and this angle. It gives us this picture here. We're looking for corresponding, which might take us a second to really look at it, but it shows us a parallel line right here and a parallel line right here. So therefore, the transversal that cuts through that parallel line, those parallel lines is right here. And then we can say that this angle and this angle are corresponding, so therefore they're equal. So we can say angle VSU equals angle WUT. It says WUT is kind of small. Okay, continuing down the page, we do have some review from yesterday. For these, we're just going to determine whether we can say they're congruent based on side, 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 or side, angle, side. So looking at number 1, we have angle, side, side, angle, side, side. That would be ASS, which isn't a congruent statement, so no, we can't prove that those are congruent. They could be, but we can't prove it. And then over here, we have side, angle, and then a shared side. So that shared side is equal to itself, so then we have side, angle, side, side, angle, side. And number 3, the shared side is equal to itself, so that would give us side, side, side. And for number 4, another shared side. But in this case, we would have angle, side, side, which, as you know, isn't a congruent statement. So we can't prove congruence here. But there's one more thing that I do want to go over that doesn't show up in these notes, but it does come up sometimes. There is one situation where ASS will work, and it's in right triangles. So I'm going to draw 2 right triangles. And they don't call it the ASS theorem. They call it actually hypotenuse leg, HL. Hypotenuse leg. And it's only for right triangles. And so if you have 2 right triangles and it has a hypotenuse in common, like the same length, and it has a leg with the same length, then these 2 right triangles are congruent. So it's called the hypotenuse leg theorem. If in two right triangles a hypotenuse and one leg are congruent, then they are congruent. But look, it does have the ASS, but the only way that ASS works is with right triangles. Okay, now we're going to actually practice some proofs. So just flip over to this page, zoom out, label it proof practice. Okay, so like I said, these will start feeling a lot easier than they have in the past. Here it says given CE is congruent to AC, so I'm just looking at the picture and making sure I understand what it's saying. Okay, CE is equal to AC. And it says ER is congruent to AR, so again, just identifying what it's talking about. Okay, so it has two sides congruent so far. And we're trying to prove that these triangles are congruent. Got it. So they wrote the two givens that were just written up here, and then we need a third statement, and it says that the reason is reflexive property of congruence, so obviously they want us to write that this side equals itself. So segment CR is congruent to itself. You can make a little mark if you want. And then we can prove that these two triangles are congruent because of side, side, side. Okay, then the next one, our given is that R is the midpoint of AG and ET. So point R right here is the midpoint of AG, is this segment here. And it says it's the midpoint of ET, which is this segment here. So since R is the midpoint, and they already wrote that given statement in here, then we can say that this segment is equal to this one. And we can also say that this segment is equal to this one. And the reason is definition of midpoint, we just have to write the statement here. So GR is congruent to RA. And then we can say that TR is congruent to RE. And then this next step, it says angle GRT, so that's this angle here, is equal to ARE, this angle. Well, those are equal because of vertical angle theorem. And then last but not least, we can say that these two triangles are congruent. And the reason why we can say that is because we have side angle side, side angle side congruence. Some of the ones on the homework take this a step further, and they'll have another step, and they'll say, okay, now I can say that angle T is equal to angle E. And the reason why you could say that is because of that theorem CPCTC, congruent, oh wait, I read that. Congruent parts of congruent triangles are congruent. Did I say that right? Congruent parts of congruent triangles are congruent. So this is the theorem that says that, okay, once you have congruent triangles, then you could say that any of the parts are congruent. So it's CPCTC. Okay, next page, just continuing. Prove the triangle is congruent using side, 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 or side angle side. They gave us a given. I'm going to put the given statement in here. AB is congruent to BC. And AD is congruent to CD. These are given and given. Then, of course, I'm going to make sure I know what they're talking about. AB and BC right here. Got it. This is equal to this. Okay. I'm trying to prove that they are congruent. The next step would be to prove that this is equal to itself. So BD is congruent to BD because of the reflexive property. And now I have all three sides equal, so I can say that triangle ABC is congruent to triangle CBD because of side, side, side. And I'm done. We don't need the last space. And the last one here. First thing I'm going to do is just write the given statements in. Okay, I'm going to look at the givens in comparison to the picture just so I know what's going on. Okay, so AB equals BC, got it. And then it says that BD, this segment right here, bisects the angle ABC. So with it bisecting that angle, then I know that this angle is going to be congruent to this one. So I need to write that angle ABD is congruent to angle CBD. And the reason why I know that is definition of angle bisector. Okay, so we have a side in common, we have an angle in common. I can prove that this side is equal to itself. So I can say that BD is congruent to BD from the reflexive property. And now I have side angle side. So now I can say that those triangles are congruent because of side angle side. Easy enough. Okay, there is one question on the homework I want to go over just so that nobody gets stuck on it.